Fourier series does not exist for all periodic signals. There are certain conditions to be satisfied for the existence of Fourier series. And these conditions was first given by the German mathematician Dirichlet, and hence the name Dirichlet's conditions. Consider the second statement. X of t must have a finite number of maxima and minima during any single period of the signal. To understand this, consider these two waveforms. First, consider the signal x1t. The time period of the signal is t0. That is from here to here. t0 minus 0 is equal to t0. First, we can find out the number of maxima in this signal in one time period. Here only one maxima is present from the interval 0 to t0. Therefore, there is only one maxima, that is, the maxima is finite. To find minima, consider this interval, that is from t0 by 2 to 3t0 by 2. That is also t0. That is 3t0 by 2 minus t0 by 2. That is 2t0 by 2, that is equal to t0. In this interval also there is only one minima. So, the number of maxima and minima is finite in this waveform. Therefore, the second condition is satisfied. Now, consider the second signal. Here we can see that this is the time period. That is from 0 to t0. The time period is t0 itself. And in this interval, there is infinite number of maxima as well as infinite number of minima. Therefore, the second condition is violated. Now consider the third condition. X of t must have a finite number of discontinuities. To understand this, consider these two waveforms. First, consider the square waveform. The time period is from this point to this point, that is t0. That is positive portion, that is up, high plus low. Discontinuity means a sudden change or transition. Here there is a sudden change from 0 to 1. So there is one discontinuity. Here also there is a change from high to low. Therefore this is the second discontinuity. Here also it changes from 0 to 1. So this is the third discontinuity. So in one time period there is 3 discontinuity. That is, the number of discontinuities is finite. Therefore the third condition is satisfied. Now consider this waveform. Here from the figure it is clear that this waveform is periodic, but we can see that there are infinite number of discontinuities in this single time period. So the third condition is violated. Now consider the statement, this over any period the waveform or the signal should be absolutely integrable. That is, the value should be finite. Consider these two waveforms. In the first waveform, the time period is t0. So we have to integrate the signal from 0 to t0, x1t dt, and from the waveform it is clear that for 0 to t by 2 the value is a, and from t0 by 2 to t0 the value is 0. So substitute this in this equation, from 0 to t by 2 a dt plus integral t0 by 2 to t0 dt. Integrating, we will get it as a into t0 by 2. This value is finite and it is less than infinity. So the first condition is satisfied. Now consider the second waveform. This is the waveform for the tan function, and we all know that when t is equal to pi by 2, tan pi by 2, the value is infinity. Therefore, this condition is violated.